Hey everyone, let's talk composition of functions. We've got three functions given up here. F of x equals 3 minus 4x, g of x equals 2x squared, and h of x equals x plus 1. When you have a composition of functions that you need to do, you may see it given like this, which is read f of g of x, or like this, also read f of g of x. I always prefer to write them this way, so even if the exercise is given like this, I rewrite it this way to show that I'm going to nest the g of x function inside the function f. So the g of x will be the inside function, the f of x is the outside function. How do we write that? It's going to be a matter of copying and substituting. I will copy the f of x function down here, but when I get to an x, I'm going to leave parentheses. So 3 minus 4, right, instead of that x, I'm putting parentheses. And what I put into the parentheses is whatever this function is asking for here, in this case, our g of x. So 2x squared goes into there. My next step will be to simplify. So 3 minus, and then 4 times 2x squared gives me 8x squared. So let's do another one. G of f of x. Again, I'm going to copy. As soon as I get to an x, I'll put parentheses, and then of course copy the rest of the expression. So g of x 2, and then x is there, so I put parentheses, and then I know that's squared. And what do I put into the parentheses? I put f of x, so that's 3 minus 4x. Now, if I want to multiply this out, I'll get 2 times the quantity 9 minus 24x plus 16x squared. And that's just multiplying this 3 minus 4x times itself to square it. And then distributing that 2 over all of that, I'll get 2 minus 9, 18, and then minus 48x plus 32x squared. Now, looking at these, one thing that stands out is that when I compose f of g of x, I get a different answer than when I compose g of f of x. So I point that out to show that composition of functions is not commutative. So recall that addition and multiplication are both commutative, but we don't have that in composition of functions. They're not commutative. So please keep that in mind. Now, if you want to quiz yourself, you can take a shot at doing g of h of x and h of g of x. So pause the video if you like and try those. Okay, so again, to do the composition, we will copy and substitute. So g of h of x, I'll start copying down the function g, so which is 2 times x squared. Well, I don't want to write the x, I will write the parentheses, and then squared. Inside the parentheses, I'll put what I have for my h of x, which is x plus 1. So that, if I expand it, will be 2 times, all right, x plus 1 quantity squared is x squared plus 2x plus 1, which leaves me with 2x squared plus 4x plus 2 if I want to multiply that out. And then finally, h of g of x. All right, so our h of x function starts with an x, so I'll put the parentheses there and then plus 1. G of x is 2x squared, and then this one simplifies to 2x squared plus 1. Another thing you'll be doing when working with composition of functions is answering questions like this. What is f of g of 2, or what is g of f of 1? Well, with this, we're going to do substitution, and we're going to work from the inside out. In other words, we're going to figure out the inside function first, like what is g of 2? And then we're going to take that and we're going to plug it in to the function f. So let's do that. G of 2 is going to be equal to, and we're going to plug in 2 for x there. So that's 2, and then times 2 quantity squared. So that's 2 times 4, which is 8. And then we take that 8 and we plug it into the function f. So we write our function f, 3 minus 4, and then we get to the x and we plug in 8. So that's 3 minus 32, which equals 29, negative 29. How about g of f of 1? So here we're going to calculate that f of 1 first, work from the inside out. So f of 1, 3 minus 4 times 1 is 3 minus 4, which equals negative 1. Then we're going to take that negative 1 and plug it into the function g. So g of negative 1 equals 2 times negative 1 quantity squared, which equals 2 times 1, which equals 2. And for our last one, if you want to pause the video and quiz yourself, you might want to do that here. Okay, so h of g of 0. Okay, working from the inside out, g of 0 is 2, and then we plug in 0 for x. 2 times 0 squared, well, 0 squared is just 0. 2 times 0 is 0. Then we plug in 0 for the function h, and then we get 0 plus 1, and our answer is 1. Another thing I'll point out is, remember how we got negative 29 for f of g of 2? Well, there's another way to do that. Notice that we did figure out, in general, the formula for f of g of x, that it's 3 minus 8x squared. So we can also write f of g of x equals 3 minus 8x squared. And if we want to figure out f of g of 2, we could also just substitute 2 into what we found for f of g of x. In other words, 3 minus 8 times 2, which plugging in that 2 for that x, squared. That's 3 minus 8 times 4, which equals 3 minus 32, which equals negative 29. So we get the same thing here as we got here. So you can do these composition of function calculations either way. If you have the functions composed already and it's easier to plug into the end result of what you got, that's fine. Or if you just want to plug in and substitute, that's also fine. You get the same answer either way.